Hi guys. So I've been working a lot on the Proland integration that I mentioned in a video some time ago now, and we have here the current state of what I have for the terrain display. I'm not sure I've shown this version already somewhere else. Um, so just a quick demo maybe. So it's just displaying terrain with multiple quads and updating those quads dynamically, and you still have this wave pattern showing the consistency between the different quads. But yeah, this was really just the terrain. What I've been working on is the integration of the elevation producer to produce some elevation tiles. So simple textures where you get elevation data. So in theory, you could just start using this elevation data to shape some kind of terrain. Not just quite there yet. I mean, I'm almost there. Currently, I can generate those tiles. It's just now I need to start using them in the shader. But this is for another video, because what I want to do today is instead to focus on debugging, because yeah, this is a pretty serious part at this level. Okay, actually it is debugging right now. So maybe I can just show you, for instance. Oh, I didn't have to show you because I got a crash. So that's cool. A crash, yeah, I guess this is the only crash which is remaining. It's known to me. And yeah, maybe you can just go through this because that's a live demonstration of what you could get with the debugging process. So what's happening here is you have on the right side here a list of the threads that are currently executing in the application. At the top here, so this is in Visual Studio Code, right? At the top here, you have this little toolbar with the buttons for the debugger. You can stop the process, restart that, continue running, but when you get an exception like that, you won't go very far. These are the standard step over, step into, and step out functions. Guess I could assume that if you're interested in debugging, you probably are already aware of those functions. So as I said, on the right side, you have the list of threads that are currently executing and the call stack for all those threads. And the exception is occurring here in the thread number 28. What you can do with that, most of the time, if you're like me, assembler code is not really speaking to you, so you want to get a bit above, and you will find eventually that okay, this is an error. In this case, it's in the IMGUI implementation when it's time to do a new frame. And you can go, well, where you want actually in this call stack. And in my case, this is actually occurring when I'm starting the render process. Render process. Okay, I mean, it's this part here. You have a first task here that should be executed, then a second task, and a third one. And all of them are grouped together and they should be executed one after another. And in turnouts, in this case of IMGUI at least, that sometimes you are going to execute this once, and then I think it's here. When you do the submit with true, you're going to finalize the rendering of the GUI. But this could happen in any thread currently. And the next time when you're done with that, you have additional task for the actual display, and eventually you would come back to the render task again, and you would again start with task 1. But this could also be executed on any thread now. And it seems that IMGUI is not happy with that. Because it's expecting those values to be the same, and actually it will see that they are not the same. But if you look at here, you will see it's not 0 definitely, but you have 43,180, and if you look here, okay, it's the next one. So it's considering that the frame is not completed yet. But what I think this could be is really that the memory visible for this thread is not yet updated compared to the memory of the thread that actually did the update. I think that could be an explanation. So what you probably want to do is to ensure that those two parts of the rendering are done in the same thread, but yeah, currently I'm not really sure I want to do it this way. I need to think more about that. But yeah, the good thing is with this you have access to all the code stack, and when you're starting to work in a multi-threaded environment, you absolutely need that to figure out why you get your crashes. And this really helped me a lot because I had quite a lot of issues with synchronization, and without those call stacks here, I would probably still be trying to fix all of them. What is a bit of a pain, I think, is this. I can't find a mechanism to, well, expand all the threads in one click. I have to expand them manually. I should probably try to find, maybe there's a shortcut for that because it's a pain, and I need usually to do this to figure out where all the threads are, because in my case I know, for instance, that all those threads where you see moody camel, semaphore, wait, these are my worker threads, which are actually just waiting for new task to arrive, so they're not doing anything. Then you have another one here, which is in the run frame pre-render. I mean, oh, wait a second. I might still not be exactly out of the hood here, because you see here I have a thread executing render pre-render. It's not the one which is crashing, and there is another one also in pre-render, and it is crashing. I mean, in theory, I should never have a situation where I have two threads executing this function at the same time. So yeah, still something a bit strange here. So you see, this in this case is helping me to figure out, okay, I have a multi-threading issue because I have two threads trying to do the same thing, and this is not expected. Typically this is how you would figure out where you need to go next. And you can also still just look at the other threads and figure out if there's another one maybe, but usually you only have two threads that are already conflicting at a given time. Anyway, this is for the quick demonstration then of how you would use a call stack. What else do you have? Whenever you start debug process like that, it's going to create a new terminal dedicated to the debug process, and you have those outputs corresponding to the outputs of your program while running in debug mode. It's not the same as the output you could get from another terminal where you would build your project and stuff like that. So what I have in my case here are two debug configuration. So we'll see in a moment how to set this up. But first, as I said, maybe before I stop this, just a word on the variables and everything. So if I go back in pre-render, well, this one, or maybe just even this one. So here you have some variables in this context, and if you go on the debug page, you actually get some information about what are your local elements and your static or global or whatever. I'm not really using registers, checking this or anything, because, well, this is assembler stuff. I don't know, maybe it could be useful in some cases. Probably it could be useful. Well, you have a lot of stuff that are static here. So for instance, here you just add this G variable, which is a local one, and you get to know that, okay, the flag that you have here is 67, and it's initialized and so on. So that's how you could get information about what is the status of some variables. Thing is, currently it doesn't seem to be working, or is just fine for me. There's some cases where the value are not reported or reported incorrectly. For instance, when you have vectors, the size of the vector is displayed to be 0 in some cases, whereas I kind of think it's not 0. I'm not quite sure if I'm wrong or if it's actually the display which is incomplete, but yeah, you need to be careful about what you're actually reading from the value of those variables anyway. And you could also actually add stuff that you want to watch while continuing on the debug process. So you could say, okay, I want to actually watch this frame count value, so you would just select add to watch here, and that would give you your current frame count, which turns out to be the same thing as no, not exactly the same thing, because yeah, I'm missing one. Okay, and then you can of course set up breakpoints whatever you want. So if, for instance, you would like to add a breakpoint, the next time you come here, you could just come add this red point here, and that would add this additional breakpoint here, which you could just remove afterwards, and so on. You can go navigate to the previous breakpoints that you have added. As you can see, I was investigating stuff concerning the memory allocation, so trying to figure out when what's happening when I'm destroying my objects. What else do we need to mention on that? I think that's about it. Well, just here you have the list of configuration that you can start. This is if you want to add new configuration, but I'm usually not trying to do it this way. But this is to define what you're going to start next. So let's just stop this debugging process now. And if you wanted to restart that once everything is set up properly, all you need to do is select what you want to start. So currently I have those two, but if I wanted to start the previous one, I would select this here and click on this arrow to start the process. And right here, you can still use your application as usual, but it's actually debugging right now. And it means I can here, for instance, add a breakpoint in the code if I want to. One thing is, with those web GPU application, I get frame limitation when I'm displaying the view. But actually, the moment I stop displaying that, or if I, for instance, start showing the thumbnail instead, you will see that the frame rate is going astronomical. So I don't know what this is. It's some kind of synchronization of frame limitation system, but it's disabled when you're not officially showing the window. That's why when I switch a view here, the outputs here are going completely crazy and much faster. But anyway, let's just try to break in somewhere in the middle of the rendering. Where could that be? Maybe that could be in the scene manager. I know that the scene manager is going to render everything. So there would be there's a task normally. Where is the task? Process all task. Okay, this one. What do I do? Add task. I had scene process tasks. Yes, but where do I execute that? Oh yeah, it's in the engine itself. It's my task number 2 here. But yeah, I mean, I can't add a breakpoint anywhere. I could add a breakpoint here when it's time to display, for instance. And boom, I'm hitting this breakpoint now. So now you can just step over with using this button, or more conveniently, you can use F10 and F11. This one is F11 to step into, or Shift F11 to step out. Yes. So when you get here, if you want to step over, which is the most common thing you want to do probably, is just F10. So that would move you to the next line. Now, if you need to check what's happening into this present function, you use F11 to enter. So you get into the function. So now F10, what do? You're going to lock this dev spin lock. Then you're going to call this function. And now you could try to get out of this call. So Shift F11. And then you can continue, move to the next one. Oops. Yeah, okay. And so on. So you can resume the run with this continue function F5, but it's going to break again on the next execution of this function. So every time I hit F5, it's going to run that. You see that the variables are not updated immediately. Maybe you need to wait a little bit. But yeah, I mean, it's working pretty fine. So let's just, remove that. Now resume rendering, F5. Now it's going to go crazy. And now let's just try to close the process, maybe normally, or maybe stop somewhere in the deletion process here. When I'm about to check if I have any memory leak, for instance, I could just stop here before checking if it's empty or not. And now if I close this, I should arrive here, and you have access here to a map. But as I said, you have ref. It's a map, but it's reporting that the size of the map is 0. I mean, it's probably 0 in this case, but the thing is, the only value I've seen so far is 0 for this size thing, so we're not quite sure it's working fine. And in this case, okay, no memory leak, so we should be good. And now we can resume running, and it's actually finishing the process. So yes, that's it for everything I need to mention on the interface itself. Now, I've been demonstrating all this, and I'm not even talking about what it is. So what I've started to use here is the extension for Visual Studio Code, which is called CodeLLDB, which is a debugger from the LLVM tool chain, if you want. LLDB, I mean. CodeLLDB is a kind of special implementation because I think it's kind of integrating the debugger directly into the extension itself, so it doesn't depend on an external debugger. You could also, in theory, use an external. I mean, you have different debuggers first. GDB, LLDB, or Windows debugger, and so on. And you can set them up differently in Visual Studio Code. And in fact, you can add different configuration in parallel, I think. But for the CodeLLDB, it's not depending on an external source, because otherwise you could also, I can just show you that here, when you build LLVM or when you get the binaries for LLVM, if you go in the bin folder, you should find the LLDB here. That's a debugger itself, but you don't need to provide those external binaries to use the code LLDB. First thing you want to do then to use this extension is to install this one, and you see that it's very popular, and there's a lot of installation already. And once you have installed that, next thing you need to do is to, well, actually ensure that you can build your application in debug mode. So in my case, I can show you the CMake file. Currently, I'm already just focusing on in the case of compiling with CLang. So if you arrive here with CLang compilation, you would normally set up some flags for your compilation. This is the common flags, and then what is important is here you would set up additional flags. Actually, this also is important, differently depending on whether you want to compile with debug support or not. The key thing is when you build a release version, you want to use this optimization free, and when you build with debug mode in mind, you want to use this J free. Actually, so far we're just using J, but there are a few additional stuff that you can add here, and in fact I should probably mention that. Let me just find the link. It's this one. Wait, give me a sec. Okay, here is a page. It's an article I found about what are the, well, interesting flags that you can use when building with CLang, and also when trying to focus on debugging. So I got some ideas here on how to set up stuff. What did I keep? I think currently I'm mostly keeping this one to get all the warnings. I'm not using extra yet. Maybe I could try that now, but well. So this is an interesting article if you want to read that. And then the other part, which is interesting here, is the dynamic runtime checks, where you want to use this sanitize command lines elements. Except that in my case, it's not quite working. I mean, I just need to come back to that in a moment. What I wanted to say is, I think it's here also that he said that using J3 is a good thing compared to, yes, debug information. I was doing that before, just using the J, but it seems that this could be a better way to do it. Okay, and what I was saying next is about those sanitize address and sanitize and define. I think this could be very interesting stuff to enable in your command line. I've never really used that, and I'm not quite sure what would be the interest of that in the end, but yeah, I would like to try it, except that it's not working for me because I'm using the version of LLVM that I built myself in NervLand, and this one doesn't provide the the library that we need for sanitize LRS. So probably there's something I'm not building correctly. And for the other one, sanitize undefined, when I'm trying to use that currently, I have an issue because the library itself here, I mean, it's going to link to an additional library, and that library is expecting the empty static release linkage. But in some of the libraries that I'm using currently, I'm using the dynamic release of the runtime linkage. So this is incompatible, and I need to, well, try to use that differently. I mean, there could be some sub-project where I could still link, but I need to investigate this part. Anyway, what is important, as I said, is this one. Also, you want to disable any kind of optimization, and those flags, maybe debug and non-debug in this case. And this one really is really good because it's going to give you a lot of warnings, and you can, you know, clean your code a lot with that. And after that, there would be special customization, I guess. So you need to set up properly your debug command lines, your debug flags, I mean. And what next? Next, you need to go into add configuration or open configurations in the run menu here, and this is going to open the launch JSON file, which is located in your VSCode folder. So you could just go there also, I guess, and that's where you would create additional debugging or launch configurations. So you could just come here, and I could say, okay, maybe I want to add a new configuration, and to use the CodeLLDB, which you should already have installed at this point, you add those entries here, and you want to, most of the time, use this one, CodeLLDB launch. And that, when you click on that, is going to add a new entry. You don't want to touch the type, the request either. The name is going to be what will be visible then in this list here. So you want this to match I don't know, a meaningful name for you. Let's say in this case I want to create a new configuration for another application. What do I have? Let me just find another one. Where am I? Now I need to go in test. What could I test? I don't know. Let's just take one of the last one. Yeah, let's go with damage element. So I'm going to use this application. So I would go here, and I would say this is WGPU damage element, and it's going to use, well, the location is my workspace dist folder. This is the location that I have here. It's actually where I have all the binaries, so you also have the executable files here. And the application is well, this one. Just replacing the application name with, sorry, I thought I had still that copied, but no. And that. So now you have an additional configuration entry. And you save this file, of course. What did I change here? Okay. And now you can go on this tab for debugging, and you can select your new launch configuration. And again, you can use this button here to start, or just press F5, in fact, to start the debug process. And now it's going to create, in fact, an additional terminal here dedicated to the debugging process for this application. So F5. So you have the new one here, and it's starting the application. And then is working as I've demonstrated before. You can put your breakpoints, and you can wait for crashes or whatever, and you can start debugging your process. So yes, I think this is covering everything I needed to mention concerning this new tool, which is my new best friend. Because yeah, if you want to start debugging in a multi-threaded environment, okay, so that's normal. At some point, you really need to use a debugger because it's becoming very crazy. I mean, it can debug. It can become pretty crazy to debug stuff like that. Okay, so I hope this was an interesting tutorial to someone, and you learn a little bit how to use this tool. If you have any questions, just let me know in the comments, and I try to see if I can help or provide more details or anything. And then meanwhile, happy coding on your side, and see you next time. Bye bye.